Good morning students. In this class we are going to discuss about anionic polymerization. Anionic polymerization is nothing but a chain growth polymerization similar to free radical and cationic polymerization. We are going to discuss the mechanism of anionic polymerization. As discussed in free radical and cationic polymerization, we have three steps that is involved here: initiation, propagation as well as termination. Now let us go to the topic anionic polymerization. Anionic is a form of chain growth polymerization or addition polymerization that involves polymerization of the monomers which is initiated with the help of anions. This type of reactions has many manifestations, but traditionally we are using vinyl monomers. As discussed, it takes place in three steps: initiation, propagation and termination. Initiation is started with the help of initiators, and initiators is selected based on the reactivity of monomers. Highly electrophilic monomers such as cyanoacrylates can be taken. They require weakly nucleophilic initiators like nucleophilic initiators such as amines, phosphines or halides. Less reactive monomers such as styrene will require a powerful nucleophile such as butyl lithium. So you have a less reactive monomer such as styrene. To initiate anionic polymerization reaction, you need a powerful nucleophile such as butyl lithium. Next we have an intermediate strength monomer. You can take an intermediate strength having initiator such as vinyl pyridine. So you can take a highly electrophilic monomer. You can take amines. For less reactive monomer you can take butyl lithium, and for an intermediate strength monomer you can take vinyl pyridine. The solvent used in this all processes is determined by reactivity of both the initiator as well as the nature of the propagating chain that you are using, and you can use a wide range of solvents. Coming to the mechanism of this butyl lithium, using butyl lithium, let us take, this is butyl lithium. You have 4 carbon atoms. 1, 2, 3, 4 carbon atoms, butyl lithium. What happens during the initiation process is a positive lithium cation and a negative anion, butyl anion is formed. Lithium cation and butyl anion is formed during the process, and the negative charge, as this is having a negative charge, we call this as carbanion. You can see this is the carbanion. We can also name this carbanion. Carbon atom already has 8 electrons. This carbon atom already has 8 electrons in its outermost shell, which it shares with the atoms, all the surrounding atoms that it is bonded with, and so the pair of these electrons, the carbon-carbon double bond, is shifted over here during the process, which can be written like this. And what happens here? Again, this bond, it is shifted over here and settle on the other carbon atom. The negative, it will settle on the other carbon atom double bond, which forms a new carbanion. With the negative charge resting on this new carbon. So the new carbon is formed, and the process in which the butyl lithium falls apart and the butyl anion reacts with the monomer is called as initiation. So this process is called as initiation. The whole process here, it is called as the initiation. This is also the part of the initiation process. What happens then? You take n molecules of the monomer, it reacts here and the product formed during propagation step. So this step is nothing but propagation, the second step. So here you have both the initiation steps and this is the propagation step. In a propagation step, the product formed will be like something like this: CH3, CH2, 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 C, HH, and again you have HH. So this is your initial reactant. So I am writing the reactant again, HH, and again HH. So if I need to write the lithium ion, I can write it, or you can just leave writing the lithium ion. So again you can form during the propagation step also a new carbanion is formed, where this will be repeated n times and your product will be C single bond C. After termination your product will be like this, CHH. So this is a simple reaction where an ethylene molecule reacts, as in the previous examples we took only the ethylene molecules. Therefore what happens, I took an ethylene molecule as an example, and the initiation step is the carbanion formation, and finally you can get ethylene polymer. So this is what a common anionic polymerization appears to be. Now let us take an example of amine. Shall we take the example of amine? Anionic polymerization of amines. The amine NaNH2, it dissociates into sodium ion and NH2 minus. We have this minus and this amine. Let us take the monomer as styrene. I am giving you another example where we saw, initially we saw about butyl lithium. Now we are going to discuss how this carbanion formation is with styrene and your amine. See, I can give it as C6H5, right? So this is your styrene molecule, or you can also draw a ring like this. That is not a problem. You can give a similar structure. The structure will be the same. So this is your initiation step, and then we have your propagation step. What happens in the propagation step is, let us take, this is your rest of the chain, and CH2, C, you have this styrene molecule, and the monomer reacts so there is a bond shift like this, electron shift. Again you have the rest of the chain here, CH2, CH, you have this styrene, CH, the carbanion is the new center, and this is your propagation step. And of course termination step, in the termination step you will get n times. So this is the termination type where you get polystyrene. But actually during this process there may be the formation of a product like this due to this, from this, okay, from here, plus ammonia. So what happens, your product may be, this is the rest of your chain, From the ammonia, there is proton transfer from here to here. So, as there is proton transfer, what happens? CH2, and again you will get H2 plus NH2 minus. So, if a solvent that is able to release a proton react with the positive active site, ammonia is such an example. This reacts and H plus it goes, reacts over here, and the chain may be terminated like this, and this is called as chain transfer. Chain transfer may occur. So, what happens here is during an anionic polymerization, during this type of anionic polymerization, a chain transfer may occur or the chain may not terminate at all. Anionic polymerization, it will go for long days. Therefore, what we have to do is you can add monomer 1 and monomer 2 to terminate the chain. Or you can add some more amount of ammonia or solvents to terminate the chain. So, anionic polymerization is progressive and takes long days to complete the reaction. So, some of the monomers with the monomer styrene, usually you add ethylene. Monomer will be added to terminate the reaction. So, if styrene is taken, you can add ethylene monomer to terminate the reaction. So, this is how anionic polymerization is followed. Now, thank you for the session. Let us now move on to Ziegler-Natta polymerization, which will be discussed in next class.